Okay, so again, yesterday we talked about just the basic limit, how to solve it graphically in all three cases that we saw, and then how to plug and chug, right? So your first attempt is to plug and chug. Put it in and see what happens, right? So let's look at one where that doesn't work, and I'll show you how to algebraically change it so that it does. Okay, so what we're going to do is take the limit as x approaches 4, and we'll have x squared minus 2x minus 8 over x squared minus 4x. Plug and chug, that's the first thing you do every time. What do we get? Okay. Is that an answer?
No.
No. Okay. This is what we call an indeterminate form. Okay. This tells us nothing. Okay. It tells us there's a discontinuity of some kind. Okay. That's what it tells us, not nothing. Okay, so it can either be infinite or point. Okay. On one, the limit does not exist. On the other, it does. So we need to figure out which one it is algebraically. Okay. Can you use algebra to change that equation or that function, whatever it is? Yeah. How can we manipulate this here algebraically? And we're thinking all the review material we went over the last few weeks. Can I do that?
No.
That's an algebra atrocity, folks. Don't ever do that again. Mike, you just got off the hook. Okay, what can we do to that algebraically? The big F word, factor. Okay. Factor them, top and bottom.
I don't like the F word.
The top becomes and the bottom. Just factor the common x out. Okay, same problem. Jose, what can we do now? No, we already tried that. Kayla.
You can cross out the x minus 4.
X minus 4s are now legal to be canceled because they're multiplied by everything else. Okay, so what you end up with, x plus 2 over x. Oops. Plug and chug again. Yep, simplify, 3 over 2. You have your limit now. This is because we could factor, it's a point discontinuity. Okay. So it's just a hole. There's a hole in the graph there. If it was not factorable or anything, if we can't do anything to it, it's an infinite discontinuity.
So it might
Yes. So limits can be very useful in telling us what our graph looks like at certain points. Okay. Good? Easy enough? You can handle that?
Yeah.
Okay, let's try one more. Well, the limit as h approaches 0, h cubed minus 4h squared minus 6h over h. Okay, you get an indeterminate form?
Yeah.
Yeah, very, very good. Okay, can you factor both of them in some way or another? Well, the bottom's untouchable, but the top. You can. Now we can cancel the h's out. Plug it in. Plug it in. Done. Okay. So again, we know when x is 0, oop, it's -6. I better do something. There is a point discontinuity at that spot. Okay. The limit exists. There's just no point there, no location. Okay. You think you can handle these? I'm trying to think of one to use that has an infinite discontinuity, but basically what you see is you can't factor. It's an indeterminate form and you can't do anything with it. And I don't think you're going to run across any of them today. Okay. That's it. Okay. So trying to just add a little bit at a time. There it is. Remember, this is, we'll make this due tomorrow. You could probably finish it on, so you have 25 minutes. Remember the spiraling? I'll write it down again. I haven't decided that. Ouch. Let's see. I will consider it. I have to look at my plans before I make that determination. That's what it means. It might already be that way. It might